We're going to talk about tomato and pepper. And I've worked with tomato in the past, but mainly with whole tomatoes. So fresh cut tomatoes, I've done a little bit of work, but nowhere close to Marita. So these two vegetables belong to the family of what we call the mature fruit vegetables. And other examples are peppers, chilies, squashes, pumpkins, tomatoes, and melons. And it's very important to remember when we're talking about those crops that maturity at harvest is really important for the quality of the fresh cut product we want to have. They're chilling sensitive, but they vary in sensitivity, and ethylene can control ripening. They have moderate respiration rates, and they can be stored for quite a while. So I was working a little bit, like looking at the different types of fresh cut tomatoes that are out there. I don't know, what do you guys produce? Does anybody produce fresh cut tomatoes here? Which of the three do you, just sliced? Okay. Okay, yeah. It's a really ubiquitous crop. So I was like checking different uses, and it, from like burgers to Greek salad, I'm Greek, to Mexican, like chipotle and stuff. And I even found this, and I was like, oh my God. You can't even, people have packaged tomatoes, they put in their face. I'm like, well, new markets. Anyways, back to reality and physiology. Tomatoes, the quality attributes of tomato. It's important to know the size and the shape of the tomato that you're working with. You have to have a good incoming product, no damage or decay. And the texture is important because, as we say, usually the quality only goes down. You can't improve the quality of the product that you have. So you have to have a firm fruit. Mealiness is not liked by the consumers. You want it juicy, and you want to have good slice integrity. And I'm going to show you some data later about that. Red color is related to lycopene content, and people are looking for antioxidants. Lycopene is an antioxidant, so tomato consumption is associated with high lycopene intake. Flavor and composition is important, of course. We have improved a little bit our quality in that aspect, but we're not there yet. So flavor and composition is a direct relationship between all of those there: sugars, acids, volatiles, and vitamins. So moving on, we use this chart, which is a little complicated, but it kind of shows you what's happening in a tomato throughout its post-harvest life. So the MG thing that you see here means mature green, and then we go all the way to red. We usually like to buy vine-ripe tomatoes. Does any of you know what vine-ripe means? Which of all these is vine-ripe? 1, 2, 3, 4, 5, 6. Yes, 5? Just 5?
No.
6?
2 all the way across.
There you go. 2 to 6. So long as there's some color on the skin, you can call it vine ripe. So it's really interesting. So as you can see, the respiration rate increases. Typical climacteric fruit. Some things decrease, like the green color, acidity, starch, and the firmness goes down, and then some others increase. Red and yellow color, aroma, flavor, sugars, and so on. So often when we talk about slicing tomatoes, usually mature green fruit ends up being sliced because it has less locular tissue internally, and it slices better than vine-ripe fruit. That's another here photo that shows the relationship between the hue values that we can get using a colorimeter and lycopene content. So you see, the lower the hue values, the higher the lycopene amount in the fruit. And then you have the different stages of tomatoes. This is an example of some work that was done at Marita's lab again. Different varieties of tomatoes show different leakage in the container. You see packaging, similar, same color, but different leakage. And that's important to know when you select your varieties. Slice integrity. For you guys that you do, sliced tomatoes, it's really important. So again, Marita's lab, I'm going to keep talking about you because you did a lot of work with slice integrity. They came up with a great idea on how to measure the integrity of tomato. So the way they did it is they took whole fruit and they weighed them. Then they cut them using different methods. And then they measured the juice loss. So depending on how much of the weight was lost, they could categorize it into from very firm to very soft. So imagine if it lost 0 to 2% was a firm fruit, very firm, and if it lost more than 10, it was a very soft fruit. Okay, so quick question for you. Which of these 6 slices you think are good for human consumption, for the market? The first line, the second line, or which of the 6? Anybody has any idea? Which one would your customers prefer?
The ones that have less juice.
Okay. Okay, so yeah, exactly. So locular tissue space is an issue. So here you have some locular tissue space, and it can get much worse, like here, for example. And then on the bottom, you have translucency, which is also a problem. For the green locular tissue, it's often due to damage, due to mechanical damage. So we tend to beat up our tomatoes a lot. So, you want to reduce the mechanical damage because it's cumulative. It can happen from the farm, during harvesting, shipping, packing, and then when you cut it, you end up with a product that people take a look at it, at their burger, and they're like, oh my God, this is a green, ugly, locular tissue. A very interesting experiment here. They took this little plastic tube that was 1 and 2 feet long, and they took some small 67-gram steel balls. You can see it here. So they dropped it. They knew the exact height, and they let it hit the tomato multiple times. So what they did is they categorized the tomatoes into severely damaged and no damage at all, when there was no impact of this metal ball. So you can see the difference after 3 hours after the damage, a day, 5 days, and 10 days after damage. So you see there's a big difference between the no damage and the severely damaged. Similarly, slices of tomatoes, even at higher temperatures. Okay, let me explain that. This is a little counterintuitive. You have from 0, 3, 7, 10, and 13 days. This is no damage. This is 1 foot height and 2 feet height. And here's the average that you want to look at here. So you had less juice loss at the tomatoes that were impacted by the ball, which has been explained by an enzyme that's in the tomato. It's called pectin methylesterase that could have been induced during the impact, and that probably reduced the juice leakage. For translucency, there was higher translucency for damaged fruit, and you can see that here. The no damaged fruit had lower translucency scores compared to the 1 and 2 feet damaged fruit. Some general quality attributes of tomato for fresh cut uses. Different varieties have different final product. The maturity at harvest, as I mentioned, is important. You want to minimize physical injury. Storage duration and temperature is important, as well as the ripening conditions. And here you see different diced tomatoes, different cultivars have varying products. So when we talk about post-harvest conditions for whole tomatoes, what do you guys use? Does any of you handle whole tomatoes, or you only do fresh cut? What temperature do you guys use?
Never lower than 52.
Never? Okay, good. I'm happy to hear that the industry has adapted, because back in the day, they used to go less than 50, 45, 7.5 degrees was a few years ago. So as you said, 50 is the bare minimum, 52, 55 is the suggested temperature. The shelf life is about 2 to 3 weeks. Controlled atmospheres have been used, and I've worked with them, but not that I know of for whole tomatoes. Commercially, they're not being used. You guys don't use any? Oh, yeah. Okay, the humidity is about 85 to 90%, and you want to ripen them between 15 and 25 degrees Celsius, or 59 to 77. 68 Fahrenheit is the best suggested temperature. Here's a little crowded table. Here you see the effect of temperature on ripening rates of conventional tomatoes. So you see the ripeness stage, initially mature green, breaker, turning, and pink, and the different temperatures from 55 all the way to 77. How many days it takes for those tomatoes to get to full red coloration at each temperature. I was digging through the literature, and I'm going to try not to get too much into it. Of course, as you probably know by now, CA can only supplement cold storage. Okay? Some scientists worked with different regimes from 3% oxygen plus 0% CO2, or 3% oxygen and 3% CO2, which ended up reducing ethylene production. They used sodium hypochlorite, potassium bicarbonate, as well as calcium lactate to extend the shelf life of fresh-cut tomatoes. They did it for surface sterilization, but they showed that this can help extend the shelf life of the final product. Also, almost 10 years ago now, no, 20 years ago, 1999, they showed that they can use water-absorbent paper in the trays to avoid the juice accumulation. Do you guys use that at all, or it's not used anymore? Do you use any pads or any absorbent paper? You do for your product?
It's standard, right?
Is it?
Montrose? What's the company that provides it?
Montrose Hauser.
Yeah.
Yeah, so it's pretty.
There's a couple other companies for sliced tomatoes and diced tomatoes.
It's pretty standard, yes.
Some kind of technology that separates the purge or liquid from the tomato so that it's not sitting
Right.
in its own primordial ooze.
But not for all diced tomato. I've seen diced tomatoes that are just, you know.
It's more common in sliced, actually, than diced, and primarily in food service applications.
Yeah. And then ripening slices at 20 to 25 degrees in humidified atmospheres showed that with 9 to or 20 microliters per liter ethylene can reduce seed germination, which is an example I showed yesterday, the viviparous seeds. So these are some graphs from the same work. It was done in Spain, and you can see on the left the ethylene production. It's really tiny amounts, and you can see when you hold your fruit at 2 degrees Celsius, which is how many Fahrenheit?
2 is about
35 Fahrenheit. You can suppress the ethylene production in both whole and fresh cut fruit, versus when you have your fruit at a higher temperature, about 50 degrees Fahrenheit, you have a significantly increased ethylene production. So you can see again, temperature. Similarly, when we're talking about oxygen and CO2 accumulation, when you start with a traditional modified atmosphere and you close a bag, you see here the oxygen levels at 2 degrees go down. But at 10 degrees, you have a much sharper decline in the oxygen levels and a much higher rise on the CO2 levels. And you can have potentially damaging conditions. These might be negative for the final product. When you flush your bags with CO2 and you reduce the oxygen rates, you have similar results, but it's not as sharp of a decline. So after 10 days, quality attributes of tomato maintained better at 2 degrees compared to 10 at this study, and they found out that during storage at 2, they had better results under active or passive MAP. In the same study, calcium chloride dips were useful only at the lower temperature, at 2 degrees Celsius, in maintaining the quality of tomato. And active MAP should only be used for tomatoes stored at 10 degrees, at 50 degrees Fahrenheit. This is another study that was done with a number of different tomato varieties that have different shapes and sizes. And as we know, lately, for the past 10 years, grape tomatoes are considered to be really the best tasting tomatoes. And that's explained because they have really high soluble solids and a good balance between the acidity and soluble solids. According to our studies, tomatoes can last up to 18 days at lower temperatures, grape tomatoes. They perform well in trays since they're never left out of the low temperature storage to show the chilling injury. So what happens is we chill those tomatoes, but when people take them out, usually they eat them right away. They don't leave them on the counter for a few days. If you do the same with a big beef steak tomato and you take it out, eventually you're going to have pitting and decay. But when something is part of a tray, usually you put some dressing, you mix it, and you eat it. So you kind of trick the customer. You don't trick them. They don't get to see what you did to the tomato, but you have to do it to keep the whole tray safe. You can't store leafy greens at 10 degrees Celsius. It's impossible. And you also have high water loss if you leave grape tomatoes out at higher temperatures. More examples here of the composition of ripe grape tomatoes. According to studies, we showed that the minimum harvest stage should be stage 4, somewhere here, for these tomatoes. And you can slow down the ripening process with temperature, which works out fine. But if you use MCP, which is not used from what I know for tomatoes, you can block the ethylene receptors, and then tomatoes will take too long because they will never ripen. So MCP is not being used. Does any of you use MCP for tomatoes? No, right? Okay, so shriveling and dehydration, that's another big problem for tomatoes. And you see here a scale for scoring the shriveling symptoms from none, number 1, to 5, which is severe. And we showed how there's a direct correlation between the shrivel score and the weight loss. So it's a direct result of water loss. Also, we found there is an inverse correlation between the firmness in Newton force and weight loss. So the more water it loses, the less firm the product is, which makes sense. Moving on, that's a study about 10 years ago in grape tomatoes, which was stored in plastic clamshells at 4 different temperatures: 5 degrees, 41, 50, 59, and 68. And what we did is we scored them from visual quality. The higher the number, the better the quality. So you see how storing them at temperatures 41 to 50 Fahrenheit maintained the quality much better, the visual quality, compared to the higher temperatures. Going to weight loss, of course, the lower the temperature, the less weight loss we saw in our grape tomatoes. Firmness had similar results, but there were less of a difference between 41 and 50 degrees. And red coloration, the higher the temperature, the more quickly the red color appeared in our cherry tomatoes.
So can I just add one
Yes,
thing?
please.
So the implication there is that putting grape tomatoes on the vegetable trays, they must be red when you put them on the trays. Even we have evidence after this is they actually lose some of the red color at the low temperature. So the idea there is that, if you put them in and they're only partially red, they're never going to turn red. So they have to be at red color because at 41, they're incapable of synthesizing the red pigment. So that's the important point, the most important point.
Another thing that I noticed is that the shelf life was much shorter in the higher temperature. So for 5 degrees, you had an extra, how many days is that? 5 days, 6 days longer shelf life, right?
Yeah. We did several experiments, so the idea there is they wanted the vegetable trays up to 18 days, and so that's why we started adding 18 days at that temperature, but not the other temperatures, right? We were focused on how do they perform at 41, right? That was a surprise. I thought we would show that, it wasn't a good temperature, but no, my respects to the grape tomatoes.
They do better than you expect. Yeah. Any of you produces? No, thank you for adding this. Any of you produces something like that, like a tray? Do you guys produce it? How many days is your shelf life? I was always wondering.
That's a good question.
I mean, it's fine. Yeah, just out of curiosity. How much time do I have, Jeff?
About 10 minutes,
Oh.
11 minutes.
Oh, wow. All right. So grape tomatoes can tolerate a wide range of modified atmospheres. And here we use 5 different regimes: air, 10% CO2 and 12%, 10% oxygen and 12% CO2, 3 plus 18, 3 plus 12, 3 plus 7. So you see the visual quality, all the modified atmospheres did better than the air, but there was not a huge difference between them. You see how small this bar is? There's no difference between all of them, but the air was significantly lower. There was a lower visual quality score. For discoloration, again, not a huge difference. The air did a little worse than the rest, but nothing very dramatic. Dehydration, similar things, not a huge difference. But for decay, you can see how there's a big difference between the air-stored tomatoes and the ones that were under modified atmosphere. And that's towards the end of their shelf life. In the beginning, they were all the same. There was no difference pretty much. So for longer storage duration, here you can see a big difference, but for shorter, if you want to store them up to 9 or 12 days, they didn't show any difference. So for grape tomatoes and post-harvest handling, you want to have high flavor quality, and as Marita said, you want to use red tomatoes when you put them in trays, because they might lose some of their coloration later. They're susceptible to water loss, and they can tolerate a wide range of modified atmospheres. The recommendation, as we have for years, is not to store them below 10 degrees Celsius or 50 degrees Fahrenheit. But in reality, because we're mixing them with fresh cut celery and carrots and stuff, we have them at less than 5 degrees for 2 to 3 weeks. Moving on to peppers. I have a few more minutes for peppers. Yes.
Is the same care with heirloom tomato?
For both heirloom tomato, heirloom are bigger.
The different colors.
The same temperature, the same care,
Yeah.
the same conditions.
Yes.
Yeah, all tomatoes usually, when we're talking about whole fruit, we want them at less than 50, no less than 50%, 50 Fahrenheit. But for smaller cherry tomatoes, we say that since they go into a tray, they can go to a lower temperature. But when you talk about whole tomatoes, you want 50 Fahrenheit or higher. Do you have anything to add on that?
No, that's it.
Yeah.